Earlier today, I published a short about whether you could see the Artemis mission from the Earth. Essentially, we talked about angular resolution, which is a determining factor about what level of detail you can see. Essentially, if you have a small angular resolution, you can see more detail, and so we needed a very small angular resolution to potentially see the Artemis mission around the moon. So I thought it would be fun to kind of talk about how can you find out what angular resolution your telescope or apparatus has. Basically, angular resolution varies by wavelength. So if we were looking at red light or blue light, it will vary. But let's assume we're interested in visible light. You have a telescope, you're going to see what the visible spectrum is. Well, we can calculate our angular resolution using this formula here. So R is equal to lambda over D, and then this factor here converts this into arc second. So lambda is our wavelength, and D is the diameter of our telescope, or I believe that's the aperture of the telescope. Anyways, what we'll do is we'll do a little sample calculation using our lovely green light, which is about halfway through the visible spectrum, so 550 nanometers. And let's say we're interested in a 30 centimeter wide diameter telescope. So that'll be about a foot for all you Americans. And we'll do a little bit of a calculation. So using those values, we will find that our angular resolution for a 30 centimeter telescope is going to be 0.38 arc seconds, which isn't too bad, all things considered. Now, this of course is going to be limited by the atmosphere if you're viewing from Earth. That impacts the available resolution, so that'll usually limit us to about 0.4 to potentially even 1 arc second, depending on how bad the pollution is. But yeah, that is how you determine what sort of resolution your telescope has for whatever given wavelength. So with that in mind, I hope you enjoyed, and if you like this sort of content, subscribe. I do physics stuff. So this is what the channel does. Anyways, see you around.